I'm going to let the number of red tokens in the bag be X. And if the question say that the first two draws are both red tokens, that means the probability of getting for the first draw to be a red token will be X over 15 because there are going to be 15 tokens in total. Then the second draw must also be a red token, so it is going to be X minus 1 over 14. And the question tells me that the probability of this happening is 1 over 35. So this is 1 over 35. With this, it is x. X minus 1 is equal to 15 times 14 over 35. So here I have a x squared minus x. This is going to be equal to 6. Okay, so x squared minus x minus 6 is equal to 0. It will be x minus 3. And x plus 2 is equal to 0. So x is going to be equal to minus 2 or x is going to be equal to 3. Okay, and x cannot be a negative value since x is the number of red tokens. So x is equal to 3, okay, which is what the question wants us to show. For the second draw to be either a red or a green token, okay, there can be two scenarios. The first scenario is when the first draw is not a red or green, okay, that means the probability is going to be 2 over 15, okay, because there are only 13 red or green, so not a red or green is going to be 2. Okay, so 2 over 15, then the second draw it is a red or green. There are 13 of them, so it is going to be 13 over 14. Okay, another possibility is that both the draws, the first and the second draw, both are red or green. Okay, so for the first draw to be either a red or green, it is going to be 13 over 15. Okay, and for the second draw to be also red or green, it is going to be 12 over 14. Okay, if you were to calculate this is equal to 13 over 15. What we want to find now, it is the probability of event A union event B. We are just going to make use of the equation that for this that is given in our outline. It is probability of A plus the probability of B minus the probability of A intersect B. Well, let's first try to calculate the probability of A. Probability of A is the probability that the participant were to, if the participant were to draw his or her second red token on the third draw. Okay, for the second token to be drawn on the third draw, okay, the probability can be calculated by looking at it in terms of two scenarios. The first scenario is this. The first scenario is when the first draw, okay, it is not going to be a red colored draw. It is not going to be a red colored token, so it is going to be red is 3, so the non-red is going to be 12. So 12 over 15. Okay, then the second one is going to be red. So if the second one is going to be red, it is going to be 3 over 14. Okay, and the third one is also going to be red because event A is for the second red token to be drawn on the third draw. Okay, so it is going to be non-red, red, and then red. To be red again, it is going to be 2 over 13. Okay, or another possible scenario is that the first draw is already a red colored token, so it is going to be 3 over 15. Okay, then a non-red colored token, it is going to be 12 over 14. Okay, and then a red colored token, so it is going to be equal to 2 over 13. Okay, and this is the probability of A. Okay, next, let's try to calculate the probability of B, which is that the participant were to draw a blue token on the second draw. Okay, and there can also be two cases. The first case will be when the first one is not a blue token. So for it not to be a blue token, it is going to be 13 over 15. Okay, then followed by a blue token, there are two blues, so 2 over 14. Or another case is that the first one is already a blue token, so 2 over 15. Then the second one is also a blue token, so 1 over 14. Okay, and this is our probability for B. Then minus away the last probability. This probability is for the red token to be drawn during the third draw, and the second draw has to be a blue token. Okay, so in order for that to happen, the first draw must be red. Okay, because the second one got to be a blue token. So the first one to be red, it is going to be 3 over 15. Okay, then it is going to be followed by a blue token. Okay, so it is going to be 2 over 14. Okay, and the third one is going to be the second red colored token that is going to be drawn. So it is 2 over 13. Okay, because one of them is already drawn here. Okay, so this is going to be the probability of A intersect B. So this plus this minus away this. My final answer is going to be equal to 248 divided by 1365. There are two tests that we have discussed in our outline, okay, about the test for independence. I'm going to use one of them here to test whether events A and B, they are independent of each other. Okay, first, from part 3, we have gotten the fact that probability of A intersect B is equal to 2 over 455. What I'm going to do is I'm going to compare this to probability of A multiplied by probability of B. Okay, and from part 3, probability of A is 24 over 455. Probability of B is 2 over 15. Okay, if I were to multiply these two together, I'm going to be getting a 16 over 2275. Okay, and this is not the same as probability of A intersect B. Okay, and according to what we have discussed in outline, if this is not equal to this, then A and B, they are not independent events.